Equations in slope-intercept form. We've talked about graphing an equation with a table, with intercepts. And now we're going to learn about graphing them in slope-intercept form. And I feel assured by the time we're finished with all of this, this will be your favorite way. This is the way I always default to when I'm trying to graph a line. To me, it's just the easiest way. But what you need to know first is slope-intercept form. Slope-intercept form looks like this. Y equals mx plus b. Okay? Your x and y are just your x and y, just your coordinates. Okay? Remember I told you the other day, m is always going to represent the slope of the line. B is going to be your y-intercept. Now tell me again, what is a y-intercept? It is where the line crosses the y-axis. So if I know a point, I know a slope, and I know, well, you don't need, as long as I know two of those, actually, you can graph anything. If I know a point, a slope, or the y-intercept, I can graph a line. Now, for example, if I had y equals 3x plus 7, and I ask you to tell me what is the slope. Well, my slope, in this case, we're just going to use m, okay? My slope is 3. My y-intercept is 7. So it's going to cross my y-axis at 7 and have a slope of 3. If I gave you the equation y is equal to 1/2 x minus 3, then my slope is equal to 1/2, and my y-intercept is equal to -3. Okay, because I have that minus 3 right there. That makes that a -3 for my y-intercept. Okay, so slope-intercept form. Y equals mx plus b, where m is the slope and b is your y-intercept. Okay, now let's look at some problems using that. So it says write an equation in slope-intercept form of the line with a slope of 1/4 and a y-intercept of -1. Then graph the line. Well, remember my slope-intercept form is y equals mx plus b. Now, let's plug in what we know. Y is just going to be my ordered pair. I don't know what that is right now. M is my slope, and it told me I have a slope of 1/4 x. That's my ordered pair. And my y-intercept of b is -1, so I'm going to have -1. So that's the equation of the line in slope-intercept form. All I did was have to plug in my slope and my y-intercept. Now, let me show you how easy these are to graph. You don't have to make the tables, you don't have to figure intercepts, you don't have to do any of that. I know it's going to cross my y-axis at -1 because my y-intercept is -1. So I'm going to put a dot on my y-axis at -1. Now I have a slope of 1/4. So I'm going to go what? What does that mean? I mean, that slope is 1/4, and that means what? Rise over run. So I'm going to rise 1 and run 1, 2, 3, 4. Rise 1 and run +4, right? 1, 2, 3, 4. And then you can draw your line. That's my rise over run. That's using your slope. So if I have that y-intercept, notice I start, when I do in my slope, I'm starting from that point. You're not starting from the origin, starting from the middle. You're starting from the y-intercept. You're starting from the point you know, and then you're doing rise over run. Okay? All right. Look at this one. Look at another one. It says graph this. 5x plus 4y is equal to 8. Now, you know you could graph that with intercepts, or you could graph that with a table. But now you know slope-intercept form. Why not take that equation, 5x plus 4y equals to 8, and put it in slope-intercept form? Meaning I want to get it in the form of y equals mx plus b. So I need to get my x on the other side, so let's subtract 5x. So I have 4y equals, and that's just going, I'm just going to write that as a negative 5x plus 8, because I just subtracted 5x, so that's going to be a negative 5x. Got to get the y by itself, so I've got to divide everything on both sides by 4. So now my 4's cancel out. I get y is equal to a negative 5/4 x plus 2. Am I in slope-intercept form? Y equals mx plus b. Yes. Now this is so easy to graph. My y-intercept is 2, so I'm going to go up to 2 on my y, and then my slope is negative 5/4, so that's negative 5/4. Negative 5 is my rise, 4 is my run. So to go negative 5 on my rise, that means I'm going to go down 5. 1, 2, 3, 4, 5. And then I'm going to run a positive 4, so I'm going to the right. 1, 2, 3, 4. Down 5. 1, 2, 3, 4, 5. Run 4. 1, 2, 3, 4. Now, just so you can see, could I also have written that as 5 over negative 4? Yes. So go back up here to my y-intercept. So I could have risen a positive 5, 1, 2, 3, 4, 5, and run and left a negative 4, 1, 2, 3, 4. And there's my point. And then all you have to do is draw your line. Isn't that so much easier than graphing with a table or graphing with intercepts? Just put it in slope-intercept form and you've got it basically done. It's just a matter of plotting the points and counting the rise over the run. All right, look at another problem. If I just had y equals negative 7, I just wanted to put this in there so you remember, what do you do? What does that mean when I have y equals negative 7? Well, where's y always going to be negative 7? 1, 2, 3, 4, 5, 6, 7. Y is always going to be negative 7. Again, if you wanted to think of that in slope-intercept form, though, y equals what? 0x minus 7. So where's it crossing the x-axis? At negative 7. What's my slope? 0. And we know 0 is a horizontal line. Or basically, I'm not going to go up, and I'm not going to go up or down, and I can go right or left as many as I want because I just have the 0 on top of my fraction. Excuse me. All right, the next one. Look at this one. What if I gave you the line, like on this graph, and I ask you to find which equation is in slope-intercept form? Well, I know my slope-intercept form is y equals mx plus b. My y-intercept is what? Right there, and that is negative 3. So I know that's going to be y equals mx minus 3, because that's my b is my y-intercept where it crosses my y-axis. Now I have to figure out my slope. And to figure out my slope, what am I going to do? Well, I need to find some good points that I can take. I know I've got one there. And I need to find another good place where it looks like it crosses a point exactly, maybe right there. Let me erase that so y'all can see that. See how that line crosses right exactly at that point 2, 1, it looks like. So then let's count our slope. 1, 2, 3, 4. So I rose 4, positive 4, and went to the right 2, positive 2, x minus 3, just filling it in. But what's 4 over 2? Really, I can simplify that, right? So y equals 2x minus 3 is the equation of that line, which is choice B. So you can figure the equation of the line, putting it in slope-intercept form, just by looking at the graph. Okay, one more, and then I'm going to let you be done. Look at this problem. This is taking what we're learning, because y'all are always saying, what does this have to do with anything? Well, we can apply this to real-life situations. It says the amount of money spent on Christmas gifts has increased by an average of $150,000, which is $0.15 million a year since 1986. Consumers spent $3 million on Christmas gifts in 1986. Write a linear equation to find the average amount, D, spent for any years N since 1986. So I want to find an equation to find D, the number of dollars spent. So D is going to equal what? I've got to figure that out. Well, if they spend an increasing of 0.15 million a year, so that's going to be 0.15. N is the number of years since 1986. And then in 1986, they started out with what? Spending $3 million. So I'm just using 0.15 and 3 rather than writing those out in like 150,000 or 3 million. So that's going to be my equation for finding out how much money they spent since 1986. Now, what if I ask you how much money was spent in 1999? Well, let's plug it in. D is equal to 0.15 times, all right, N is what? The number of years since 1986. So if I'm in 1999 minus 1986, that's what? 13 years. So that's the number of years since 1986 plus 3. Working that out, 0.15 times 13 is 1.95 plus 3. So D is going to be what? $4.95 million was spent on Christmas gifts in 1999. Okay? Now, you could even graph that. If I ask you to graph this equation, what you're going to do is you're going to have to draw your graph, and I'm just going to draw it like this. Okay? Now, down here across the bottom, this is going to be what? The years since 1986, and we're just going to count off the years. 1, 2, 3, 4, 5, 6, 7, 8, and so on. All right, going up on my side is going to be what? It's going to be the money in millions. All right, and we can just count by, we'll say 1 million, 2 million, 3 million, 4 million, 5 million, 6 million, and so on. So what happens? What is my equation? Remember, my equation is D equals 0.15N plus 3. Okay? So what do I know? Where am I starting? If I'm starting at 0 years, I'm going to be a what? 3 million. Okay, putting that in for my years, my N in for years. That's going to be my y-intercept is 3. Okay, and then what am I doing? What's my slope? 0.15 over 1. So I'm going up just a little bit and over 1. Up a little bit and over 1. And then you can see your line's going to kind of go like that. So again, I'm just using that slope-intercept form to make a graph of the amount of money we spend on Christmas gifts. Okay, and I just realized that this is off your recording. I'm sorry, this right here says money in millions. I'm sorry, I wrote that off of your recording. Okay, so again, go back to slope-intercept form, and y equals mx plus b. Okay, again, you just got to remember that x and y are just an ordered pair. Okay, right now you don't have those. They're just the x and the y in there, but m stands for the slope, b is the y-intercept. And you can graph that by just doing your y-intercept and doing your slope from the y-intercept. Okay, remember, to do your slope, you're going to have to start at your y-intercept, where it crosses the y-axis. All right, have a great night. I will see you tomorrow. And most important thing is what? Remember, Jesus loves you. Bye.